Hey everyone, and welcome to another deep dive.
Huh.
So your kid just started advanced programming, huh? I bet that syllabus landed with a thud on the kitchen counter. Don't worry, we've all been there.
It's true that course title alone can sound a little intimidating. But remember, your child has already dipped their toes into the coding pool, and this is just the next exciting step.
Exactly. And this deep dive is like that cheap sheet you wish you had back in school. We're diving into the advanced programming syllabus, study guides, even some exam prep to give you the inside track on what to expect this year. By the next time your kid says algorithm, you'll be tossing it right back at them like it's nothing.
I love it. And it's worth noting, this deep dive is tailored specifically for parents of kids who have some coding experience already. We're assuming they've at least built a few basic programs, maybe played around with some coding games online. If that sounds about right, you're in the right place.
Now, I took a peek at this syllabus, and let me tell you, this is not just your average type coding class anymore. We're talking databases, games, even mobile apps. This is serious stuff.
You're right, this course takes things up a notch. But instead of thinking about it like your old computer science class, imagine it more like a digital art studio crossed with a problem-solving boot camp. They'll be flexing both their creative and technical muscles, which is a powerful combination for whatever they want to do in the future.
Okay, that makes me feel a lot better. Because I have to admit, I saw the words college credit, NVCC, even Carnegie Mellon on here,
Yeah.
and I think I momentarily forgot how to parent.
It's understandable those words carry weight. What's great is that your child is in a program where they can actually earn college credit while still in high school through dual enrollment. It's a fantastic head start, and the fact that they're learning a curriculum aligned with places like Carnegie Mellon means they're getting a top-tier learning experience.
Music to this parent's ears. Okay, let's break this down a bit. The syllabus has everything divided by quarters. Quarter one is all about loops and strings. Now, those sound vaguely familiar from that intro class my kid took last year.
That's fantastic. They're building on those fundamental concepts. Think of loops like giving a computer a set of instructions it has to repeat until it gets something right. Like, imagine programming a robot to make a peanut butter and jelly sandwich. You'd have to tell it each step over and over again until it mastered the perfect PB&J.
Okay, that makes total sense. So the computer's not as smart as we think it is. It needs those step-by-step instructions, and those loops are how we make that happen. What about strings? Is that just like typing words?
Essentially, it's how computers understand and work with text. Your kid is already a texting master, right? That's all strings. Just a bit more structured so the computer doesn't misinterpret a LOL for a line of code.
Amazing. They're already way ahead of the game. Now, quarter two is where I start to get a little lost. Modeling and animating visual objects. I'm picturing robots taking over my living room. I'm not sure I'm ready for that.
Hold the robots. It's not quite that advanced yet. Think of it more like your child designing characters for a video game. But instead of those characters just standing there, they come alive, moving and interacting on the screen. They're learning the principles of making things move and groove digitally, all through code.
So they've gone from playing those coding games to
Yeah.
actually building them. That's super cool. Okay, what about quarter three? What kind of mayhem awaits us then?
Mayhem is a strong word. Let's call it organized chaos. They'll be tackling lists and complex animations. Think of lists like a super-powered shopping list for computers. Your kid will learn how to make these lists, add or remove things, and have the computer zip through them in a flash. It's all about organizing information effectively.
Okay, digital organization. I can get behind that.
Yeah.
And those complex animations, what are we talking about there?
That's where they bring those organized lists and newfound animation skills together. Imagine characters moving smoothly across the screen, objects interacting in intricate ways. It's about making those digital creations feel more dynamic and lifelike.
Okay, I have to admit that's pretty impressive. But quarter four is where I officially tap out. We've got sets and dictionaries, recursion, and the one that makes me shudder, object-oriented programming.
Help. Don't worry, it's not as scary as it sounds. Those are definitely some bigger, more abstract ideas. But the main thing to remember is that these concepts build upon everything they've learned in the previous quarters. It's like they're learning the alphabet, then grammar, and finally, they're ready to write a novel. These are the tools they'll need to build truly impressive programs.
Okay, that makes sense. But with all this fancy coding jargon, it's easy to get lost in the weeds. So can you break it down for us? What are the real skills my kid will walk away with? Like, how does this translate into, life skills, not just tech stuff?
You're going to be surprised at how much of this translates beyond the computer screen. One of the biggest takeaways is learning to write efficient code. Think of it like this. It's one thing to write a rambling paragraph, but it's much more impressive to deliver your message with clarity and precision. It's the same with code. They're learning to get the job done with elegance and efficiency, just like a wordsmith crafts a perfect sentence.
So it's not just knowing the code, it's knowing how to use it well. That totally applies to life in general. What else? What other superpowers will they gain from this course?
Problem solving, that's the heart of programming. They'll be learning to look at a challenge. Maybe it's organizing their music library or designing a simple game and breaking it down into steps the computer can understand. It's like they're learning to speak the computer's language to make it do amazing things.
So instead of just consuming technology, they're learning to create it. That's a game changer. And speaking of games, the syllabus mentions something about them designing a pretty big one at the end of the course.
It's true. They'll be putting all those skills to the test by building their own version of Tetris from scratch.
Wait, Tetris? Like the classic video game Tetris. I can barely play the game, let alone build it.
I know, right? It's impressive stuff. But it's not just about recreating the game. They're learning the entire design process, from brainstorming ideas to planning the code to actually building and testing their creation. They even get to add their own unique twist to the game.
Now that's what I call creative freedom. I'm already picturing parent-teacher night with them demoing their personalized Tetris game. I might be more excited than they are. But let's be real, there's always a point in the semester when the panic sets in and we hear those dreaded words, "Mom, I need help with my coding homework." How can we help our kids without, actually doing their homework for them?
I'm so glad you asked. Those study guides we mentioned earlier, those are gold. They're packed with helpful tips and hints. For example, Unit 1 really emphasizes understanding those basic data types: integers, floats, strings. They might sound intimidating, but they're the building blocks of everything. It's like making sure the foundation of their coding knowledge is rock solid before they start building those digital skyscrapers.
So it's all about mastering those fundamentals
Right.
early on. That makes sense. What about Unit 2? What kind of guidance does the study guide offer there?
Unit 2 is all about practice, practice, practice. This is where those loops we talked about earlier really come into play. And this is another great opportunity to engage with your child's learning without needing to be a coding whiz. Ask them to show you a loop they're working on and try to explain it to you.
That's a great idea. It's a win-win. They get to practice explaining their thought process, and we get a glimpse into their coding world. And it seems like things get really exciting in Unit 3. Am I right?
Absolutely. Unit 3 is where things get interactive and visual. Remember how engaged your child is when they're playing those app games? Well, now they're going to be the ones creating those effects, making things happen on screen with a click or a key press. They're going to be learning about events like a mouse click, a key being pressed, or even just time passing, and how to make their code respond to those events.
Oh, wow. So they're not just making things move around on the screen. They're making them interactive. That's next level stuff.
Exactly. And that level of interactivity is what makes this unit so engaging for a lot of students. They get to see the results of their work in a really immediate visual way, which can be super rewarding.
Okay, so they've mastered the basics. They're building interactive programs, and now they're tackling Tetris. This is feeling less like a high school class and more like the origin story of a superhero programmer.
That's a great way to put it. And speaking of superpowers, remember how we talked about object-oriented programming? That's where it really shines. With OOP, your child learns to create reusable code. It's like having superpowers. They can build bigger, more complex programs much faster.
Okay, that actually makes OOP sound kind of cool. It's like they're not just building one-off projects anymore. They're creating systems and tools they can use over and over again.
Exactly. And that kind of thinking, that's what sets them up for success, not just in programming, but in any field, because it's all about problem solving, right?
Absolutely. So to wrap things up, it seems like this advanced programming course is about way more than just teaching kids how to code. It's about building those fundamental problem-solving, creative thinking, and design skills that can translate to pretty much any field they choose to pursue later on.
Couldn't have said it better myself. It's about equipping them with a toolkit for success, no matter what path they choose.
Well, there you have it, folks. We've gone from feeling intimidated by the syllabus to practically ready to code Tetris ourselves. Almost.
We might need a whole other deep dive for that.
Maybe so.
Yeah.
But in all seriousness, I hope this deep dive has given you a clearer picture of what to expect this year in advanced programming. Remember, it's okay to feel a little lost at times. Just embrace the journey, ask questions, and who knows, you might even surprise yourself with how much you learn along the way.
You never know. You might even spark a newfound passion for coding yourself.
Now, wouldn't that be something? All right, everyone, Go forth and confidently navigate the exciting world of advanced programming. We'll catch you in the next deep dive.